So hello and welcome back dear students. Today we are having a new video number 11, and so we are going to record lecture number 11 this time, and time is almost this pen is not working. Lecture number 11 we are going to record, and time is almost 2 o'clock to 8. I hope you are enjoying the thermodynamics series. Very soon it will be completed. Hope tomorrow I will complete the full chapter, and after that we'll start that question discussion. In this video, we are going to discuss about the Hess law. So I'm not going to take more time. This video going to be start Hess law. What is Hess law, children? According to this concept, like one reaction is given A to B, and here enthalpy changes delta H. Then in the second case, A to C, and enthalpy changes delta H1, and C to B, enthalpy changes delta H2. If you will add this equation, then C cancel, then what you will get A to B. In that case, delta H1 plus delta H2 is equal to delta H. That is the concept of Hess law. Delta H is equal to sum of these two equations. That is your Hess law. Okay, like how? Suppose from carbon solid is forming 1 by 2 O2 and it is forming CO gas. Here delta H is minus X. At the same time, CO plus half O2, it is forming CO2 gas. Then delta H is equal to minus Y. Then what is, find the heat of reaction? What is delta HR? In that case, how to find, children? You have to add this equation. When you will add this, then what happened? CO will be cancelled. Then carbon solid. Okay, the wait 1 minute. Here it is CO, and here it is CO. And they are asking enthalpy of this reaction. CS plus O2, it gives CO2. What is delta H for this? Enthalpy of reaction for this. So how this reaction you will get by the addition. You can add, this will be cancelled, then you will get this reaction. So delta H is equal to minus X plus minus Y. So ultimately delta H is equal to minus X minus Y. That will be the enthalpy of this reaction. So that is the utilization of Hess law. You are getting my point? Yes, of course you are getting. Now more examples, like one equation is given Fe2O3 plus 3CO, it is forming 2Fe plus 3CO2. Here delta H1 is equal to minus 26 kilojoule, and at the same time FeO plus CO, here we are getting Fe plus CO2, and delta H2 is given 16 kilojoule. The question is, find delta H for the reaction. Which reaction? Fe2O3 plus CO, it gives 2FeO plus CO2. So think about it, children. How will you get this reaction? It's a simple concept here. no need to worry. You want Fe2O3, where Fe2O3? Here, one Fe2O3, but Fe2O3 you want. So this is equation number 1 and this is equation number 2. So equation number 1 as it is, there is no need to multiply anything. FeO, FeO this side, here it is in right side, here it is in left side, and 1, then here 2 FeO required, here 1. So this equation is multiplied by 2 and minus. Reverse, you have to reverse the equation. So if you are reversing the equation, then what happened? That means what you have to apply? Required equation. How to get required equation? By equation number 1 minus 2 equation number 2 into equation number 2. This formula you have to apply. Check it. Equation number 1. So it will be Fe2O3 plus 3CO, then minus 2 FeO, left side add, minus CO, plus gives 2 Fe plus 3 CO2 minus 2 Fe minus 2 CO2. Then solve it. FeO as it is, 2 FeO, we want 2 FeOs, then it will be transferred CO. So 2 CO. And how many CO is required? 1 CO only. So 3 CO, oh sorry, here it will be 2 CO, multiply, forget, 2 CO. So now Fe2O3, 3 CO, 2 CO, then plus CO, it gives Fe transferred that side, FeO, so it will be 2 FeO and plus CO2, 2 CO2, then plus 1 CO2 only. Okay, that you are getting 2 Fe cancel. So that is your required equation you got. So how to find enthalpy? So delta H is equal to now delta H1 minus 2 into delta H2. Put the value. In that cases, put the value. So H1 is what? 26. So minus 26 minus 2 into minus 16 minus plus. So it will be 16 to the 32, then plus 32. So it will be plus 6 kilojoule. That is your answer. Delta H in that case. Like that we'll solve problem related to the Hess law. Next question. Find the enthalpy of reaction. Find the enthalpy something problem. Find the enthalpy of reaction. So my suggestion is, children, before my solution you have to try. You can pause the video when you are watching. First you will try and then see the solution. Find the enthalpy of reaction C2H6 plus 7 by 2 O2. It gives 2 CO2 plus 3 H2O. What is delta H for this reaction? They are asking. If the enthalpy of formation, delta HF of C2H6, CO2 and H2O are minus 20 kilocalorie, minus 90 kilocalorie, minus 70 kilocalorie. That information is given. So write the equation for the enthalpy of formation. Enthalpy of formation of C2H6. First they have given C2H6. So how to find C2H6? Check it, children. C2H6 enthalpy of formation, that means only one mole. C2H6. So 2C plus 3H2. Carbon is solid. Then delta H is equal to 20 kilocalorie. Then enthalpy of formation of CO2, then C solid plus O2, then it will form CO2. Here delta H2 is equal to what? Minus 90 kilocalorie. And then enthalpy of formation of H2O, then what? H2 plus half O2. Here delta H3 is equal to minus 70 kilocalorie. Options are given. Option number 1, minus 400, minus 370, C is minus 360, D is minus 420. These are the options. So in the required equation, what you want? C2H6. So C2H6 in reverse, then it is multiplied with minus 1 because we want right left side. CO2, 2 CO2 we want. So here 1 CO2 is there, then this is multiplied by 2. And H2O, 3 H2O is required, then this is multiplied by 3. That's it. So that application you applied required equation. How will you get required equation? Minus equation number 1 plus 2 into equation number 2 plus 3 into equation number 3. So direct I am showing the equation minus 1. So here check it. I'm not going to do again and again. So 2C minus 2C and here plus 2C. So this will be cancelled. 3H2 minus 3H2 and here minus multiplied by 3 minus 3H2 cancel. Then it will be reverse. So what you will get? C2H6 plus O2. How many O2? Here it is 7 by 2 O2 is required. So in that case, this case 2O2 and plus 3 by 2 O2 means 2 plus 3 by 2. So what it will be? 2. So it is 4. 4 plus 3, 7. Okay. So 7 by 2, correct. 7 by 2 O2. It gives remaining what? 3H2O. 3H2O is coming from here and 2 CO2 from here plus 2 CO2. So in the enthalpy also same thing you have to apply minus 1. So enthalpy it is what? 20. This is 20. So minus 20 plus 2 into minus 90 plus 3 into minus 70. So if you will solve this, then minus 370 answer will come. Got it? So like that we can solve problem related to Hess law. Then 370 solved. Okay, next question. Find the enthalpy of formation. Find delta HF for acetylene C2H2 acetylene. So 1 mole, here it is 1 mole only given. So that means, so 2C solid plus H2, it is forming C2H2, not H6, C2H2. Delta H is required. If enthalpy of combustion, if delta Hc, enthalpy of combustion of carbon, hydrogen and C2H2 are minus 400 kilojoule, minus 300 kilojoule, minus 1300 kilojoule. These value will maybe differ from your book because approximately value we are using. So enthalpy of combustion is given. Write the equation now. Enthalpy of combustion. Enthalpy of combustion means you have to burn 1 mole. 1 mole carbon plus O2, it is forming 2CO2, delta H1 minus 400 kilojoule. Then H2 plus half O2 combustion, then H2O, delta H2 is equal to minus 300 kilojoule, combustion of C2H2, C2H2, C2H2 plus 5 by 2 O2, carbon dioxide, 2CO2 plus H2O, delta H3 is equal to, we have to take 1 mole only here. In all these cases 1 mole. So enthalpy of combustion defined for 1 mole. Now what you want this equation. So 2 carbon is required. So that means this equation is multiplied by 2, and here this is multiplied by 1 because only one hydrogen is required, and C2H2 right side, here left side, then it is multiplied with minus 1. So that application you have to use. So required equation, how to get required equation, children? Required equation you will get by 2 into 1 minus, sorry, plus equation number 2 minus equation number 1. Direct I am using, not going to write the equation. So here it is 2 into, so here 2, 800 minus 800 plus H2, so it will be minus 300 minus minus plus, it will be 1300. So here ultimately answer will be plus 200 kilojoule. 200 kilojoule. That is the enthalpy of formation for this acetylene. Got it? So that is the related to the Hess law. Now you can solve this by how? This by direct method, children. What is the direct method? I am telling you right now. For this equation, what is enthalpy of reaction? Enthalpy of reaction is equal to what? Enthalpy of reactant minus enthalpy of product. In the case of what? Combustion. Okay. So combustion for all. These are delta Hc. Enthalpy of combustion is given. Okay. So C plus H2, carbon plus combustion is going on. Here formation is there. Train came back 30 seconds. So in the case of combustion, we will apply. So how to find? So 2, reactant 2. So 2 into minus 400, then minus 400 then minus 300 for hydrogen, then minus, this is elemental state, free state, then uh, that C2, sorry, this C2H2 is given minus 1300. So direct you can solve, then from here also plus 200 kilojoule gain. Okay, enthalpy of reaction in the case of combustion, this formula in the case of combustion you will apply. Okay, delta R, delta reaction, enthalpy of reaction is equal to enthalpy of reactant minus enthalpy of product. In the case of formation, delta HP minus delta HR, that is used. Okay, so direct also you can solve. One more problem we will solve and we will finish this lecture, then we'll start that second law of thermodynamics. Video is almost 21 minutes. So this is all about the Hess law, children, nothing more than this. You have to practice related to the Hess law. That is the original method that you have to follow. From here your answer never will be wrong, or you can apply this method also. So that is it from the my side, children. Hope you are enjoying this thermodynamics series. Please max to max subscribe my channel and watch the video. Thank you.